In this chapter, we will explore classes and class objects in Python. A class object, also called class instance, is a collection of attributes and values. For example, the following is a tabular view of a person object. This table describes various features of one person. The left column shows a person's attributes, and the right column shows the corresponding values. For example, this person's given name is John, and his age is 54. As we can see, a class object is very similar to a dictionary, which is a collection of keys and values. A class object is an expression, so we can assign class objects to variables. For example, suppose that the variable profile contains some information about a person. To retrieve the person's age, we can write profile.age. To retrieve an attribute, we write a period in between the variable name and the attribute. If profile was a dictionary, we would write profile@age. The syntax is very similar with one key difference. While a dictionary key can be any hashable expression, object attributes must follow the same rules as variables. For example, this is an invalid expression. To update age to 27, we can write profile.age equals 27. If profile was a dictionary, we would write profile@age equals 27. Another similarity between class objects and dictionaries is that they are both stored in the object store. Thus, when we ask Python to assign a class object to a variable, Python assigns a Python reference that points to the object in the object store. So far, class objects appear to be just dictionaries with a slightly different syntax. Let's now take a look at some features that make class objects stand out from dictionaries. The biggest difference between dictionaries and class objects is that we can define and call class methods. Methods are functions that must be called with objects. Here's an example. Robot is the variable that points to a class object, and walk is the method. 5 is the method argument. We again use the period in between the variable name and the method call. Note that the method call portion, or walk5, looks exactly like a function call. Method call evaluation is also quite similar to a function call evaluation. Python jumps to the definition of the walk method and executes the method body. This means that, like functions, methods need to be defined somewhere. But unlike a function definition, a method definition must be inside a class definition. As a reminder, a function definition looks like this. And here is an example of a class and a method definition. The first line is the class declaration. The second and third lines are the method definition. Method definitions are similar to function definitions except that all lines are indented by one more tab, and the first method parameter is always the method call object, which is robot in our example. We can have many method definitions inside a class definition. Here's an example. As we can see, classes give us the ability to group related functions. Note that dictionaries also have methods, such as keys. However, all dictionary methods are built in. We cannot define custom dictionary methods.